Welcome to the user interface of the PathoINVEST tool. This software application provides first responders with the capability to monitor, address, and evaluate the impact of a pathogen contamination event in the drinking water network. In this presentation, we will utilize a case study of a pathogen contamination event to showcase the tool's diverse features. These functionalities range from early prediction of contaminant evolution over time to evaluating the impact on the population from various contamination scenarios, to ultimately identifying the source of contamination via active sampling. In the contamination scenario, a certain contamination volume and time is preset as default. The tool can model the pathogen indicator Escherichia coli and 5 reference pathogens. 1 bacterium, that is Campylobacter, 2 viruses, enterovirus and norovirus, and a parasitic protozoan that is Cryptosporidium, that differ in their infectivity, persistence and resistance to residual disinfection. To initiate the tool's functions, we will first click on the Run Scenarios button located on the left-hand panel in the Applications section. This action opens the option for the user to select the location or locations that may be considered a potential source of contamination. When there is more than one potential source, the user can opt to choose a single source or a combination of 2 from the total potential sources, acknowledging the possibility of multiple contaminations occurring simultaneously. For instance, if the user considers 5 locations and selects the Single Source button, then only those 5 locations are considered as potential sources. In contrast, selecting the Combination of 2 Sources button enables the tool to calculate all potential combinations as possible sources, resulting in 15 possible combinations in this example, which are the original 5 and the 10 potential combinations. The user can choose the locations from the map by selecting the Select from Map button and dragging the mouse to highlight multiple locations on the map. Once the desired locations are selected, the user can import them by clicking on the Import Selected button, which displays the selected locations in a table along with their respective nodes. The tool provides options to highlight the selected nodes on the map, deselect all selected nodes, or delete specific nodes from the table. Once the user finalizes the contamination sources, they can click on the Run button, and the tool initiates the calculation of the hydraulics and quality dynamics based on the EPANET MATLAB toolkit. Once the user has selected the locations of potential contamination sources, in this example, 5 single-source locations, they can then view the contamination evolution for the various sources by clicking on the Contaminant Evolution button on the left-hand panel in the Applications section. At this point, the user can select their preferred type of demonstration. The first option is the convex hull-based visualization, which generates a GIF with coloring shapes. Each shape represents different time steps, providing the user with a visual representation of the contamination evolution. Alternatively, the user can select the network-based option, which creates an MP4 highlighting the contaminated nodes alongside their respective concentration over time. This option allows the user to track the contamination's progression within the network and determine the severity of the contamination at specific nodes. After selecting one of the 2 options, the user clicks on the Run button, and then after waiting for a moment, the user can select for which contamination scenario they want to generate the visualization. In addition to monitoring the contamination evolution, the PathoINVEST tool also enables users to assess the potential impact of each selected contamination scenario. By clicking on the Impact Assessment button located on the left-hand panel in the Applications section, the tool calculates the impact over time, which is defined as the percentage of people ingesting more than one colony-forming unit of the contaminant. The user has the option to select the time frame of which the impact is assessed and then click the Run button. This feature allows first responders to quickly evaluate the potential health risks associated with each selected contamination scenario, and to prioritize their response efforts accordingly. Finally, the user has the option to locate the contamination source based on active sampling. This is achieved by clicking on the Sample Locations button on the left-hand panel in the Applications section. The user can then indicate the area where they want to perform manual sampling within the network to identify the source. In this example, since the potential contamination sources are located on the western part of the network, we focus there and select the sampling locations. The user can click on the Select from Map button and drag the mouse on the network to highlight the sampling locations. Once the sampling locations have been selected, the user can import them into the table by clicking the Import Selected button. Other options from this application include viewing the selected sampling locations on the map again, deselecting all locations, or deleting a specific sampling location. Once the user is certain about the preferred sampling locations, they click the Run button. Next, a table is generated where the rows correspond to all the potential contamination scenarios and the columns to the selected sampling nodes. Each node contains a binary signature for each contamination scenario, 0 indicating no contaminant passing through the node, and 1 indicating contamination. This information is generated after the tool has run and calculated the contaminant evolution for all the potential contamination scenarios. The user can click on a specific scenario and see the selected sampling locations on the map alongside their respective signature with colors: red if it's 0 indicating no contamination, and green if it's 1 indicating contamination. The remaining options at this stage are to deselect any selected scenario, delete a specific scenario, or reset the table to its original form. The next step is to request a team to perform manual sampling in the field. Based on the table, the majority of the sampling nodes have an identical signature through each contamination scenario. Therefore, the user can instruct the team to perform manual sampling on the first node that has a different signature between two contamination scenarios. After identifying which node that is, and waiting for the results, the user can indicate the manual sampling result for the specific node as either positive or negative. Based on the manual sampling result and the pre-calculated binary signature, scenarios that do not correspond to reality are colored red, indicating to the user that those scenarios should be discarded. This iteration can be performed multiple times until there are no more contamination sources to be discarded. The user then receives a message indicating that the remaining scenario or scenarios are most likely to be the contamination source based on the results of active sampling. This concludes the demonstration of the PathoINVEST tool. We've shown you how this tool can support water utilities in the case of a contamination event. To understand the impact, evaluate the effect of actions to control the contamination, and locate the source of contamination. That is valuable to be prepared in the case such a contamination event occurs and rapid response is needed to limit the impact. Please stay tuned as we are working in PathoCert to develop more functionalities. For more information on this and other tools of PathoCert, please visit pathocert.eu.